Yes, folks. Hume here. How are you going? So in this video, we're going to talk about factors, multiples, and primes. Simple concepts when you really understand it. But sometimes, even when a concept is simple, it doesn't guarantee the understanding, the comprehension, so to speak. So don't feel bad. We have plenty of things in life like that. So let me go. Let me talk about multiples to start with. Multiples. And we're going to start the discussion by looking at the very word itself. The multiple. The word multiple is a noun. A multiple. And that noun is derived from the verb to multiply. So let me deal with some English here now. Have English in the maths too, you know. Or language in the maths, if you're doing the maths in a different language. Right? So to multiply is the verb. And when you multiply, what do you get? You get a multiple. So to multiply is the verb. And the multiple is the noun. Yeah? So that is as straightforward as you could get in terms of the very, 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 very basic understanding of what a multiple is. A multiple is something that you get when you multiply. Multiply what? When you multiply any number by another number. So for example, let us start with numbers that we're familiar with. Let me start with the number 2. If we want to find the multiples of 2, then what we have to do is multiply the number 2 by all the other numbers we could think of. And by numbers, we're talking here about natural numbers, as we would have discussed in a previous video. We're not talking about 0 and minus 1 and all of that. Once we're talking multiples and factors, we are talking about natural numbers, which would be your integers that are positive. We're not talking about 0. We're not talking about fractions. We're not talking about negative numbers. So what are the multiples of 2? 2 by 1 is 2. 2 by 2 is 4. 2 by 3 is 6. 2 by 4 is 8. 2 by 5 is 10. 2 by 6 is 12, etc., etc., etc. So the first multiple of 2 is 2 itself. 2 by 1. The second multiple of 2 is 4. 2 by 2 is 4. The third multiple of 2 is 2 by 3, which is 6. Sorry, the third multiple of 2, right, okay. The third multiple of 2 is 6, which is 2 by 3. The fourth multiple of 2 is 8. 2 by 4 is 8. The fifth multiple of 2 is 10, which is 2 by 5. And the sixth multiple of 2 is 12, which is 2 by 6. We could apply the same idea to the number 3. So the first multiple of 3 is 3 itself, 3 by 1. The second multiple of 3 is 6, which is 3 by 2. The third multiple of 3 is 9, which is 3 by 3. The fourth multiple of 3 is 3 by 4, which is 12. The fifth multiple of 3 is 3 by 5, which is 15. The sixth multiple of 3 is 18. 3 by 6 is 18. So let me take a bigger number. How about number 12? Not 12. We will deal with 12 later. How about number 9? The first multiple of 9 is 1. 9 by 1 is 9. The second multiple of 9 is 9 by 2, which is 18. The third multiple of 9 is 9 by 3, which is 27. The fourth multiple of 9 is 9 by 4, which is 36. The fifth multiple of 9 is 9 by 5, which is 45. The sixth multiple of 9 is 9 by 6, which is 54, etc., etc., etc. So it doesn't matter how big the number is or how small the number is. The idea is the same. You have multiples which you get by multiplying the number by some other whole number. And apart, more than just multiples itself, we could order the multiples by looking at the number that you multiply by. So when you multiply by 1, you get the first multiple. When you get multiplied by 2, you get the second multiple. When you multiply by 3, you get the third multiple. You multiply by 4, you get the fourth multiple, etc., etc., etc. And that's basically it. So if we had to list the multiples of, let me go back to the 9 we just used. If we had to write out the multiples of 9, which is a very common question in maths exams all over the world, because the concept is so important. They will actually list the multiples of 20, or list the multiples of 45, or list the multiples of 15, or list the multiples of 17, etc., etc. So let me take a big number, 17. If you want to list the multiples of 17, 17 by 1 is 17. 17, that's your first multiple. 17 by 2 is 34. That's your second multiple. 17 by 3 is 51. That's your third multiple. 17 by 4 is 68. As the fourth multiple, 17 by 5 is 85. That's the fifth multiple. 17 by 6 is 85 and 17 is 102. That's the sixth multiple. 17. How about we go back to the 9, right? We just talked about 9, so we write it on the board now. The first multiple of 9 is 9. 9 by 1 is 9. The second multiple of 9 is 18. 9 by 2 is 18. The third multiple of 9 is 27. 9 by 3 is 27. I make a proper 8 now, right? Leaning a little bit, but still. 27, not 23. The fourth multiple of 9 is 9 by 4, which is 36. The fifth multiple of 9 is 9 by 5, which is 45. The sixth multiple of 9 is 9 by 6, which is 54. Etc., etc., etc. Now, you would have realized, if you have made the connection yet, let me tell you it now. This talk about multiples is just another way of referring to your tables, your multiplication tables. If you're living in Trinidad and Tobago, then you know we have grown up with these copybooks where we have the tables at the back of the copybook. And we have the multiplication tables from 1 to 12. From 1 by 1 straight up to 12 by 12. Of course, you could go beyond that. Right? So when you talk about your 6 timetables, for example, all you're basically doing is looking at the multiples of 6. That is all. Your 6 timetables is a multiple of 6. 6 by 1 is 6, 6 by 2 is 12, 6 by 3 is 18, 6 by 4 is 24, etc., etc., etc. Your 8 timetables, multiples of 8. 8 multiplied by 1 is 8. 8 multiplied by 2 is 16. 8 multiplied by 3 is 24. 8 multiplied by 4 is 32, etc., etc., etc. That is all. So once we're talking multiples, all we're talking about is multiplication. And I'm going to use this opportunity to remind people again of the absolute necessity to know your tables, or your multiples if you want to talk about that in the context of this video. Your tables is one of those things that you simply have to memorize. You don't always have to know the deep, fundamental, philosophical reason why 9 by 6 is 24, or why 12 by 8 is 96, or why 3 by 9 is 27. Right? At this stage, you don't need to necessarily know the reason for that. We will get into that eventually. So we have to get away from this idea when we're learning maths that we have to know the reason for every single thing every single time. That is a fallacy. Right? Some things you have to learn, and yes, there will be time to get into the reason. And if you want to get into the reason, then no problem. 2022. This is the best time in the history of the world to get information. Google is your friend. Right? If you want to know why 9 by 3 is 27, then you could Google it. Why is 9 by 3 equal to 27? And I am sure somebody somewhere would have done a video or an explanation or an article or a graphic on it. So don't let the search for the reason keep you away from assimilating the facts. Don't get tired of that at all. Because at the end of the day, if we check ourselves honestly enough, there are plenty of other things that we just deal with, that we don't necessarily know how it works or why it is, but we go in still because we like it and it's nice. All right? So don't use the fact that you don't always understand the reason for something as a reason to stop you from doing the maths. We just use the word facts. So let me go straight into the discussion now. Let us talk about factors. Yes? So in the same way that we discuss multiples and multiplication and the verb to multiply, we're going to deal with the whole concept of factors. Now in mathematics, I am almost 100% sure it's simple common sense. I haven't read anything that would confirm my theory, but I suspect very strongly that the whole idea of using the word factors in maths comes from the usage of the word in English. So, if we're talking factors, the word factors, F-A-C-T-O-R, factor or factors, that concept is derived from the idea of facts. The facts of a matter. The facts of a thing. So when you're talking factors, think about facts. And if we think about it, almost everything we could think of would be, would comprise a particular set of facts that come together to make the thing what it is. Right? So let us go into a little dictionary mode here now. Right? So I'm looking at Google here. Right. Dictionary. Factor. The English usage of the word factor, according to Google's dictionary here, they say, a factor is a circumstance, a fact, a circumstance, a fact, or an influence that contributes to a result. All right? So let us say, for example, if you want the result to be passing a mathematics exam, hint, hint, right? There are a certain set of facts or factors that go into that. One factor may be your natural ability to gravitate towards numbers and figures and the concepts in there, right? Everybody has a certain amount of natural affinity for that. But that's not the only fact. That is not the only factor, right? Your own personal discipline, your consistency, whether you're coming to class, whether you're watching the videos, whether you're practicing on your own, that is a factor. And in a lot of cases, that is the most important factor. Even more important than your natural ability. Another factor might be the circumstances of your personal life. Things going on home in the house, right? If your personal life is not stable enough, it could have a negative effect on your ability to do the maths. And that is something that we all understand, and that is something that we all have to empathize with as we deal with the whole question of people doing maths. or any other thing, that's a whole big factor too. Big factor. Another factor might be the teacher. Whether the teacher good or whether the teacher ain't good, or whether the teacher care or whether the teacher don't care, whether the teacher coming or whether the teacher not coming, etc., etc., etc. That is another factor. So anything we could think of in our general life would be composed of a set of facts or factors that will interact with each other to produce a particular result. The same idea holds when we're talking about numbers. Every number that you could think of, and again, we're talking about natural numbers here now. Integers, positive integers, excluding 0. Every natural number that you could think of would be composed of a particular set of factors. Factors that interact with each other to give rise to this particular number. How do these factors interact? They interact by multiplication. So you have numbers that would multiply by each other. And when they multiply by each other, you get this number that we're thinking about. So for example, think of the number 36. What are the factors of 36? What are the numbers that will multiply together to give 36? Well, we could start with 1 and 36 for beginners, right? 1 by 36 is 36. We could try 2. 2 by 18 is 36. We could try 3. 3 by 12 is 36. We could try 4. 4 by 9 is 36. We could try 6. 6 by 6 is 36. And then, of course, 9 by 4 is 36. 12 by 3 is 36. So you're just going back in the opposite direction. So let me take the opportunity to write it down. Let me try and get the factors of 36. So the factors of 36 would be 1 by 36. Let's switch marker here. 2 by 18. 3 by 12. 4 by 9. 6 by 6. And once you get to that, then anything after that will be what? 9 by 4, which is just the same thing here, so it doesn't make any sense repeating that. 9 by 4, and then go back 12 by 3, and then 18 by 2, and then 36 by 1. So once you cross 6 by 6, you'll just be repeating yourself, because we know that multiplication is what we refer to as, take note of this word, multiplication is what we refer to as commutative, which means that the order in which you do it doesn't matter. So 2 by 3 is 6, 3 by 2 is also 6. 4 by 5 is 20, 5 by 4 is also 20. So commutative means that the direction doesn't matter, but this video is not the place for that, so we're not going to spend too much time talking about that. But I'm just throwing it in as we deal with multiplication. So the factors of 36 are the numbers that will multiply by some other number to give it 36, by some other factor. So if we identify that one particular number is a factor of 36, then whatever other number you multiply that number by to get 36, that number will also be a factor of 36. So if 4 is a factor of 36, and we know that 4 by 9 is 36, then 9 must be a factor of 36. And if 12 is a factor of 36, and we know that 12 by 3 is 36, then 3 is also a factor of 36. Etc., etc., etc. If 2 is a factor of 36, and we know that 2 multiplied by 18 is 36, then 18 is also a factor of 36. So if we had to write out the factors of 36, what would be the factors of 36? The factors of 36 would be 1. The factor of 1 is always a factor. 1 is always a factor. That is one of the properties of a number 1. Any number you think of, 1 is always a factor. 2, because we established that 2 by 18 is 36. 3, because we established that 3 by 12 is 36. 4, because we established that 4 by 9 is 36. Not 5, 6. We established that 6 by 6 is 36. 6, 7, 8, 9. 9. 9 is a factor because we know that 9 by 4 is 36. All right. Let me see, 9, 10, 11, 12. 12. We established that 12 by 3 is 36. 12, 13, 14, 15, 16, 17, 18. We established that 18 is a factor of 36. Once you get to 18, there's nothing, you can't go further than this. So once you get to 18, the next factor will be 36 itself. Because if you notice, the number that we're multiplying by will decrease as we go along. So 1, we multiply by 36 to get the 36. 2, we multiply by, sorry, hold on, let me just rub off here. I'm leading up to a particular point here. 1, we multiply by 36 to get 36. 2, we multiply by 18, right? 3, we multiply by 12 to get 36. 4, we multiply by 9. 6, we multiply by 6. 9, we multiply by 4. 12, we multiply by 3. 18, we multiply by 2. So there's nothing smaller than this, except to say that 36, you multiply by 1 to get 36. So listen to this very carefully now. Anytime you have to list the factors of any number, the greatest one will always be half of the number if the number is an even number. If the number is not an even number, then depending on what the number is, it will determine what the biggest factor is. So for example, if we have to list the factors of 27, what would be the factors of 27? 27 is 1 by 27. In fact, I'm doing something here which you wouldn't understand why I'm doing it now, but if you stay tuned to my videos, everything will tie up. Everything will come together. Right? I'm just checking my technology there. So 27 is equal to 1 by 27. 2 wouldn't go in 27, but 3 could go in 27. 3 by 9. 1, 3, 9. You can't get bigger than that. 9 by 3, well, it's 9 by 3 is the same thing as 3 by 9. Right? So 1, 3, 9, right. And that's it. Half of 27 is 13 and a half. So the 9 is not greater than 13 and a half. So in other words, anytime you have to list the factors of a number, you will not get a factor that is greater than half of a number. The only factor that is greater than half of a number is the number itself. So that when we list in the factors of 27, we will have 1, 3, 9, and then 27 itself. We will get to what we refer to as prime factors a little later, but for now, we just want to list the factors based on a simple consideration of the numbers that we could multiply to get the number that we're thinking of. All right? Now we do a few examples just to get the idea in, and then we will round off the video by considering the difference between multiples and factors, which should be clear by now, but I will illustrate it again just for the sake of driving the point home. Let me talk about the factors of 54. I just choosing random numbers, yeah? Factors of 54. Well, the first thing we do, we start with 1. Listen now, man. Simple, very powerful ideas. Anytime you have to list the factors of any number, the first factor you start with is 1. 1 is always a factor. And then when you start with 1, the next question asks is what we multiplying by 1 to get the number. The answer will always be the original number itself. So if we start with 54, and 54 is 1, first factor, multiply by what? 54. And of course, after 1 is what? 2. You try 2 and see. If it's an odd number, of course, 2 wouldn't work. But if it's an even number, then it will work. Right? So 54 is what? 2 by 27. 54 is what? After 2, we try 3. 54 is 3 by 18, right? Yes. 54 is 3 by 18. So we try 4. 4 won't go in 54. 5, no. 6, yes. 6 by 9 is 54. Anything else? 7, no. 8, no. 9, yes. So 9 will be, so in other words, when you're listing the factors, you will eventually get to a point where the order is reversed. And you start to go back to the same pairs of factors, the same pairs of numbers that you would have started with. So 1 by 54, 2 by 27, 3 by 18, 6 by 9, and then reach 9 by 6. So you don't have to go any further than that. Because anything after 9 by 6 will carry us straight to 10, 11, 12, 13, 14. Will carry us straight back to 12. No, sorry, not 12. 14, 15, 16, 17, 18. So the next pair of factors after this is 18 by 3. Look at here already. So once you get this happening, you could go back up and you have all your factors. Once you get to this point, where the order is reversed, then you know that you already have all your factors, and your next step is to just write it out. So in other words, when you're trying to find the factors of a number, do it 2 at a time now. Don't try to play hero and list out everything. Just start with 1. Make life simple for yourself. There are a lot of things that you can do. We could call it a hack if you want. Some people like to refer to it as tricks. I prefer to just say simple, plain old common sense. If you're trying to list the factors of any number, you start with 1. And then you try 2. And then you try 3. And then you try 4. And you go up the road 1 at a time. Eventually, you'll get to a point where in considering pairs of factors, you find that you have the same pair of factors and the order will be reversed. Let me just go back to the 36 because I want to make a particular point here. When we were doing 36 a while ago, we had 36 as 1 by 36. We had 2 by 18. We had 3 by 12. We had 4 by 9. We had 6 by 6. And then we had what? 9 by 4 going down the road. Same thing here. We reach 9 by 6 and we're going down the road. So, same thing happened here. We have 9 by 4 and then we have, we have 4 by 9 here and then we have 9 by 4 here. Same thing here. We have 6 by 9 and then we have 9 by 6. So once that happens, you know at that point that you have exhausted all of the available factors. And you can then set about the task of writing out the factors. Why I go through this here? Because over here, we have 6 by 6. Why we get 6 by 6? Because 36 is a perfect square. We discussed that in our previous video. So you can check it out if you want. In a perfect square, you'll come to a point where you have the two factors being the same. What we refer to, let me just call it a repeated factor for now. I'm borrowing a concept from maths a little further down the road. The use of the word repeated. Yes? So you get to a point where if the number is a perfect square, you get to a point where you have repeated factors. And once you have the repeated factors, the next pair of factors will be the reversal of the pair factors before the repeated factors. So in other words, in terms of listing out the factors one pair at a time, the difference between 36 and 54, indeed, the difference between any perfect square and what I referred to in our previous video as an imperfect square, would be that with the imperfect square, the reversal of the factors would occur right next to each other. In the perfect square, the reversal of the factors would have the repeated factors between them. All of these details are important because if you pay attention to everything I'm saying here, when we get to other topics later on, so for example, when we start to talk about factorization, if you went through this, once we get to factorization and we start to list out the factors and find the factors, a lot of things would make a lot more sense. So if you're here in the video, I trust that you're here because you were here from the beginning and you didn't just flip through and skip through and you dip and you reach here. Right? So I just want to encourage you to stay in the game. Right? It wouldn't be exciting all the time. Sometimes it might be a little longer than you would like, but I promise you, everything we discuss in these videos is important. We're not just talking for the sake of talking. You feel like they'll be tired too sometimes. But at the end of the day, we want to do the thing and we want to do it properly. Right. So, once we get to this point, we can start to list out the factors now. So in this case, if we list out the factors of 54, we can say 1, first factor, look at here. 2, second factor, look at right there. 3, third factor. Right? And then we say 6. And then the next set of factors will be the numbers that we multiply each of these things by to get 54. You see how nice it is? It's nice. So, let me start with the 6. What did we multiply 6 by to get 54? 9. Look at right there. What did we multiply 3 by to get 54? 18. What did we multiply 2 by to get 54? That would be 27. And then, of course, once you get to the half, then you know the next factor is 54 itself. What you multiply 1 by to get 54 is 54 itself. So these here are the factors of 54. We had already written the factors of 36, but I'll repeat it just for the sake of emphasis. Right? So we start with 1. Look at right here. First factor. Second factor. Third factor. Fourth factor. The fifth factor now is 6 because it's 6. So we multiply 6 by 6 as a repeated factor, so we don't put 6 here again. It's done there already. So we start now. What do we multiply 4 by to get 36? 9. And then you have 12. 3 by 12 is 36. 2 by 18 is 36. And 1 by 36 itself is 36. Now, let me make a distinction here between the first multiple and the first factor. The first factor is always 1. But the second factor is not always 2. Alright? When we multiplying, the first multiple is the number we get when we multiply by 1. The second multiple is the number we get when we multiply by 2. The third multiple is the number we get when we multiply by 3, etc., etc., etc. So with the multiples here, no problem. But the factors, however, is different. 27 is an example. The first factor of 27 is 1. The second factor of 27 is not 2 because 27 is an odd number. So with the odd numbers, you know immediately that the second factor is not 2. Right? The second factor of 27 is 3. The third factor is 9. And then the fourth factor is 27 itself. That is as far as you could get. So with the factors, it is not as neat and cute as with the multiples. The factors are not as straightforward as the multiples. But once you spend enough time with it, eventually you will become familiar with it and it wouldn't trouble you. So just as we did with the video, we start with multiples. We discuss factors. And now, should I do it as a separate video? Yeah, I'll do it as a separate video. Because one of the things that I am trying to do is not make the videos too long that people get lost. But the next question that naturally arises when you start to have that discussion is how long is long? For some people, long is 5 minutes. For some people, long is 7 minutes. For some people, long is 15 minutes. For some people, long is 30 minutes. I am not here to promise anybody that all my videos will always be 5 minutes or less. We leave that for TikTok. I am not here to promise anybody that my videos will always be less than 7 minutes or less than 15 minutes or less than half an hour or less than 45 minutes. Sometimes my videos 7 minutes, sometimes 15 minutes, sometimes half an hour. Sometimes I start to talk and explain, and then when I sit down to edit, I realize an hour, 50 something minutes. Ladies and gentlemen, boys and girls, there's a pause button on whatever device you're using for a reason. Because we understand that it is not always possible to sustain your level of attention for the whole 45 minutes or however long. It's humans. We are all humans. Pause it now. Don't use the length of the video as an excuse to not watch the video. If that is your mindset, then you ain't ready for this thing yet. Sorry to say. Alright, that is not an excuse. The video not exciting, that is not an excuse. The teacher not good looking enough, that's not an excuse. The teacher wearing old clothes, that is not an excuse. The teacher face tired, that's not an excuse. The teacher voice, I don't like his or her voice, that is not an excuse. If you're waiting for all them things to line up like stars in the solar system, then you might be waiting for a very long time. Take these silly excuses out of your thought process. Right? We're in 2022. We have a whole plethora of technological tools at our disposal. It wouldn't always be comfortable, it wouldn't always be nice, and we could always think of something else that we'd rather be doing, or some other way we'd rather be interacting. But if you're serious about it, you will get the job done. Right, so that is the closing to this video. We had a nice discussion on multiples, we had a nice discussion on factors. In the next video, I'm going to just give a very short example of the difference between multiples and factors. It should be obvious by the time you get to hear in this video, but let me leave that for our next video. Yeah? Alright, later. Boom, boom.